Hello everyone, in this video we are going to solve a problem from the topic of the Fourier transform. At first glance the problem may seem simple, but it contains many important and practical points. The problem asks us to find the Fourier transform of cosine omega 0 t multiplied by ut. To solve this problem we need a few key points. So first, let's mention these points before starting the solution. The first point is that cosine omega 0 t can be written as 1/2 times e to the power of j omega 0 t plus 1/2 times e to the power of minus j omega 0 t. The second point is that the Fourier transform of e to the power of minus at times ut can be written as 1 divided by a plus j omega, provided that the real part of a is positive. The third point is that the Fourier transform of signal ut is equal to 1 divided by j omega plus p times delta omega. And the fourth point is the frequency shifting property. According to this property, if the Fourier transform of signal x of t is x of omega, then the Fourier transform of e to the power of j omega 0 t multiplied by x of t will be x of j omega minus omega 0. Now that we have covered these key points, let's move on to solving the problem. To solve this problem, first, based on the first point, we rewrite the expression in the problem as 1/2 time e to the power of j omega 0 t times ut plus 1/2 times e to the power of minus j omega 0 t times ut. A common mistake that many students make is that they try to use the second point. They say in the first term a becomes minus j omega 0, and in the second term a becomes plus j omega 0. Then they claim that the Fourier transform of the first signal is 1 divided by minus j omega 0 plus j omega, and the Fourier transform of the second signal is 1 divided by plus j omega 0 plus j omega. After that, they simplify the result by taking a common denominator, and finally they write the Fourier transform in the form 1 over 2j times 2 omega divided by omega squared minus omega 0 squared. Then they cancel the 2 with the 2, bring j to the numerator as minus j, and they end up with minus j omega divided by omega squared minus omega 0 squared. But the solution has a major problem. In the second property, we said that the real part of a must be greater than 0. Here the real part of a is 0, and here it's also 0. So you cannot use the second property to solve this, and that answer is completely incorrect. The correct solution works like this. First, we rewrite the expression in the problem. Cosine omega 0t as 1/2 times e to the power of j omega 0t plus 1/2 times e to the power of minus j omega 0t. And then we multiply this by ut. So this becomes 1/2 times e to the power of j omega 0t times ut plus 1/2 times e to the power of minus j omega 0t times ut. Now, to find the Fourier transform of this signal, we use the third property, which says that the Fourier transform of ut is equal to 1 divided by j omega plus p delta omega. Then, using the fourth property, and we apply a frequency shift that shifts spectrum by omega 0. So the Fourier transform of the first term becomes 1/2 times 1 divided by j omega minus j omega 0 plus p delta of omega minus omega 0. In the same way, the Fourier transform of the second term becomes 1/2 times 1 divided by j omega plus j omega 0 plus p delta of omega plus omega 0. And now we obtain the Fourier transform. We just need to simplify it. If we combine the delta terms, we get p divided by 2 times delta of omega plus omega 0 plus delta of omega minus omega 0. And if we combine the two rational terms, we get So finally, the Fourier transform of cosine omega 0 t times ut can be written as p over 2 times delta of omega minus omega 0 plus delta of omega plus omega 0 plus minus j omega divided by omega squared minus omega 0 squared. If this video was helpful for you, feel free to check out the other videos on this channel for more in-depth explanations.